So the molecular formula is a whole number multiple of the empirical formula. That whole number could be 1 or 2 or 17. We don't know. We need the molar mass in order to figure out what the number is. So we're going to take the molar mass, that will have to be given to you in a problem. We're going to divide by the mass of the empirical formula. So you have either just calculated the empirical formula, or they tell you what it is. You find that mass, and you divide it into this. So this will come out to be a nice whole number unless you did something wrong. There's no rounding or multiplying. You take this number and you multiply all the subscripts in the empirical formula, and that gives you the molecular formula. So the empirical formula for fructose is CH₂O, like the first example we did. Its molar mass is 180.2 grams per mole. What's the molecular formula? Well, we need to know how many times to multiply the empirical formula. So N is going to be the molar mass of the compound divided by the mass of the empirical formula. Here's the empirical formula. We can calculate the mass of that, CH₂O. There's 1 carbon in there and 2 hydrogens and an oxygen. .026 is what my calculator is saying. And I can say that that's grams per mole. 1 mole weighs 30.026 grams. There's 30.026 grams for every 1 mole. This is much smaller than the actual molar mass. The empirical formula and the molecular formula for this compound are not the same. I want to find out how many times bigger is this number than that number. This one, 30 and 180, we can kind of just do it in our heads. It's 6, isn't it? But some of them, most of them, you can't just do in your head. So this is how you figure it out. You take that empirical formula mass and divide it into the molar mass. So 180.2 divided by 30.026. This comes out to 6.001, some other stuff. If you get a weird number here, you did something wrong. These always come out beautiful. So that tells me that I take this empirical formula and I multiply all the subscripts by 6. Don't leave it like this. That's not a correct formula. This is an illustration, a tool to show students what we're doing. The formula is C6H12O6. That's the molecular formula. You can check it by calculating the molar mass of this formula, and you should get the 180.2. One more. Butane is a compound containing carbon and hydrogen used as a fuel in butane lighters. Its empirical formula is C₂H5, and its molar mass is 58.12 grams per mole. Find its molecular formula. We need to know what number to multiply the subscripts by. So that's going to be the molar mass that's given divided by the mass of the empirical formula. We have to calculate that. We've got the empirical formula, C₂H5. 2 times 12.01 plus 5 times 1.008. .06 grams per mole. So I put that in here, 29.06 grams per mole. The units cancel out. You see that? 58.12 divided by 29.06 equals That came out exactly. It doesn't always come out exactly a whole number, but this one did. The empirical formula is twice as small as the molecular formula. The molecular formula is twice as big. So I need to take my empirical formula, C₂H5, multiply all the subscripts by 2. C₄H10. And you can check that if you want by calculating the molar mass, and you should get this one, 58.12. Questions?